In this segment on labor demand elasticity in this ongoing module, let's take a look at the concept of substitutes and complements in the labor market. So what would be a substitute? If I am a ditch digger, let's say, then I might be substitutable with someone who is more highly skilled than I am, or of equal skill. They may be able to substitute for me. So we can think of perfect substitutes as being, in this case, maybe a ditch digger and just a common laborer on a construction site. They would be able to serve similar purposes. They could be substituted one for another. So a substitute is going to have an interesting kind of relationship where we can think about what happens when the wage of one, let's say worker one, rises. What does that do then? Well, the quantity of worker one will fall. We know that this is true because we have a downward sloping labor demand curve. But if these workers are truly substitutable, and assuming the demand for the job to be done doesn't change, if the quantity of worker one fell, then that would suggest the quantity of worker two would rise, such that we're going to have some substitute, which again, this is some cross-wage elasticity since these are different workers, some substitute where we know that the change in wage, which was positive, is going to also yield some positive change in quantity, such that we end up with a positive value. Now, we don't know if it's elastic or inelastic just by the simplistic representation here, but what we know is that if a substitutable worker has an increase in wage, they're going to have a decrease in quantity of labor demanded, but assuming the job that they've been filling still needs to be done, then the worker that can substitute for them can step in, get that job done, which means that the quantity of that worker demands will increase. Well, let's think about that differently from a complement for a moment. A complement is just the opposite. Let's assume for a moment that we're on a construction site and that we're looking at carpenters. And let's also think that we're looking at plumbers. So we have carpenters and plumbers. And let's assume for a moment that they're unionized, plumbers, such that they're not allowed to do each other's job. We might be able to argue that without that kind of a rule, a carpenter and a plumber might know each other's jobs well enough to be able to substitute for each other. But in this case, we're going to think about the carpenter, and let's say that there is a wage increase for carpenters, such that now we know that the cost of that type of labor on the construction site is greater. And if the cost is greater, it's going to mean that the price of the structure being built rises. And knowing that a demand curve in the goods market is downward sloping, just like the demand curve in the labor market is, as the cost of the output good, in this case a building, rises, the number of units required will fall. Well, if that's the case, well, we already knew that as the cost rose, the quantity of them falls. But when the quantity of that type of worker, the carpenter in this case, falls, then we can also suppose that if the number of structures being built, if that's something important to us, and it is, we can suppose that if the price of the structure being built is going up, then the number of buildings being built will go down, such that the number of plumbers required will go down. So in this case, wage 2 is the carpenter wage. The quantity of labor 2 is the carpenter labor. And we know that that is a direct relationship of the downward sloping demand curve. But given that we had an increase in the wage for the carpenter, it caused us to have an increase in the cost of the building. That's a good in the goods market with the downward sloping demand curve, so we're going to expect to see fewer buildings built if they are more expensive. That would make sense to us. And if there are fewer of them built, then we need fewer plumbers to work within that same building. So we know then this is going to yield some kind of negative relationship, just the opposite of the substitutes we saw a moment ago. So in this relationship, we'll have our elasticity, our cross-wage elasticity again. But here in the denominator, we saw a positive value, so an increase in the wage, but in the numerator, a decrease in the labor units required of the other type of worker, again, plumbers and carpenters, such that we ended up with a negative value. So complements in elasticity will always have a negative value to them. And in this case, regardless of whether or not this is supply or demand, they will always have a negative value. But substitutes will always have a positive value. Their elasticity will also always be a positive value. And once again, because we know there's going to be positives and negatives, we're going to be comparing this to the absolute value of -1. That's the beauty of doing this. We look at, is it greater than, less than, or equal to when we think about the elasticity value. And obviously, if it's greater than, it's elastic. If it's less than, it's inelastic. And if it's equal to, it's unitary elastic.